Today, so I want to talk about the section 6.2 star, 3 star, 4 star, integration of logarithmic and exponential functions. This is like a 2-day lecture. So I want to follow this one. This is outline. First one, I want to give integration formulas. Second one, integration in natural logarithmic function. Third one, integration in natural exponential function. First one, integration in general exponential function. Integration in general logarithmic function. The last one, I will give more examples by using these integration rules. The first one, integration formulas. We just only think about together. First one, integral k fx dx. In this case, you can take out k times integral f of x dx. The integral f of x plus minus g of x dx, you can distribute integral like this. I have the one more question. So here, so what do you think this one? Integral f of x times g of x dx. So we can distribute integral f of x dx times integral g of x dx. So what do you think? So this statement is true or false. Could you write your answer on chatting board? This statement is true or false. What do you think? True? True? Yeah, so could you write your answer? True? 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 Okay. Thank you. All of the answering the answers of all of guys. Thank you. Really be careful. This kind of things. No, don't do that. So you cannot distribute integral to the product. So don't do that. Don't do that. This is wrong answer. Don't distribute this case. Only addition and difference. Yes, you can distribute integral. This is possible. So really be careful for this part. I'm going to give one example. The integral x times x dx. What's that? This is same to integral x squared dx. Answer is 1/3 x cubed plus c. So you can distribute integral x dx times integral x dx. So what happens? First one, 1/2x squared times 1/2x squared plus c. This is 1/4x to the 4 plus c. What happens? Totally different, right? No. So my point is, don't distribute. Don't distribute this one. The next, integral k dx. So do you remember what is integral k dx? So what is the answer? What is integral k dx? What do you think? 0? Oh, yeah. So really be careful. Thank you for your answer. Thank you very much for attending this class. This is k. Yeah, you're right. Yeah, kx. K prime equal to 0, but integral k dx is kx dx. Really be careful. The derivative integral, not dx. Kx plus c. This is answer. So we have it. The integral x to the n dx is, so we can use power rule, 1 over n plus 1 x to the n plus 1 plus c. One more, n is not equal to minus 1. N equals to minus 1, don't use power rule. So do you remember what is the integral sine x dx? What is the answer? Could you write your answer on chatting board? So what is your answer? Integral sine x dx? So what do you think? The negative cosine, cosine, negative cosine. Answer is, yeah, negative cosine. So really be careful, same thing. Sine x prime is cosine. The integral sine x dx is negative cosine. Negative cosine. Integral cosine x dx is sine. Integral secant square of x dx is tangent x plus c. Integral cosecant square of x dx is negative cotangent x plus c. Integral secant x tan x dx is secant x plus c. Integral cosecant times cotangent dx is negative cosecant x plus c. You need to memorize these basic integration formulas. You need 2 more. This is a very important thing. The substitution rule for indefinite integrals. The u equals g of x. du equals g prime of x. Integral f g of x g prime of x dx is integral f of u du. This is u substitution. So problem is given like this. How can you solve? You can check inner function. Inner function is u. You can plug. You can find differential form. du equals g prime of x dx, plug into here. We have simple form. You can find antiderivative by using integration formula like this. Find antiderivative. Next, change back. So u equals g of x. So here, you plug into here. This is final answer. This is a whole kind of things, right? So one more. Substitution rule for definite integrals. U equal to g of x, the du equals g prime of x dx, same things. So how can you solve this one? Similar. Integral here. G of x is u. You plug into here. F of u. G prime of x dx is here. du. You can change. This is the same. The only difference is lower limit, upper limit. You plug lower limit into here. Find new u value. So we have g of a. So like this one. You plug p into x again. Upper limit is g of b. This is only difference. You can change it like this here. So you need to know these 2 more important rules. The next tip. So we think about integration in natural logarithmic function. So how can you find this kind of things? I'm going to give one example. So what's it like a relation between integration and like derivative? So I'm going to give one example. But here, x squared prime is 2x. We know that. So what is integral 2x dx? What's integral 2x dx? So could you write your answer on the chatting board, please? What's integral 2x dx? Yep, x squared plus c. X squared plus c. The x square, yeah, it's good. X square plus c, yeah, x square plus c. This is like x square plus, yeah, c. This is indefinite. So let me see. What's that? This x square is exactly inside one. We call antiderivative, going backward. This is idea for finding integral things. So integration in natural logarithmic function is very similar. So let me see. You learned this stuff in last week with Kasha. So do you know this one? What is ln of absolute value of x prime? Do you know what is the answer? What's ln of absolute value of x prime? Yeah, the most value, right? Yes, 1 over x. Like this. So from here, the integral 1 over x dx is ln of absolute value of x plus c. This is idea. This is idea of a natural logarithmic function. Okay, so we have it like this. So we have it. I'm going to give one example. So how can you solve this problem? So let me see. So we have two terms in numerator. We have only one term in the denominator. What's it like the best way? You have to split first. This is better. So this one, you have to split. 2 over x squared plus x over x squared. You can change it. So what's that? So this is same to 2 times x to the negative 2. X is crossed out. This is 1 over x. So we have like this. Next to find antiderivative. How can you find? This is the same to like this. You keep coefficient 2. What is integral x to the negative 2? We can use power rule. 1 over negative 2 plus 1 x to the negative 2 plus 1. This is antiderivative. Next one, integral of 1 over x here. Integral 1 over x dx is ln of absolute value of x plus ln of absolute value of x from 1 to 2. The next, simplify. So what's that? This one is negative 1. The negative 1 times 2 is negative 2. The x to the minus 2 plus 1 is exactly x to the minus 1. X to the minus 1 is 1 over x. So we have this one plus ln of absolute value of x from 1 to 2. So we can calculate. Plug upper limit 2 into x, negative 2 over 2 plus ln of absolute value of 2 minus you plug lower limit 1 into x, negative 2 over 1 plus ln of absolute value of 1. So like this. Here, negative 2 over 2 is minus 1 plus the 2 is like a positive number. You don't need absolute value sign, or like this. This is like a negative 2 times minus 1 is negative. This is positive 2 is right here. Minus 1 times negative 2 is positive 2. What is ln of 1? Do you know ln of 1? What is ln of 1? Okay, then write the 0. Is it right? The 0? ln of 1 equal to 0? What do you think? Is it right? ln of 1 equal to 0? Yes, it's good. Thanks. This is 0. Yes. So simplify. Minus 1 plus 2 is 1 plus ln of 2. That's it. This is final answer. That's good. This is our idea for solving this problem. So like this. Next one. integral tan x dx. So let me see. Do we have a formula of integral tan x? Do you have a formula from the first page here? You can going back to the formula. So what's that? We have integral secant squared equals tan x, integral tan x dx. We don't have it. We don't have it. This one in the formula. So how can you solve this problem? This is the idea. You can use one identity. So do you know one identity of tangent of x? Integral of sine x minus integral of cosine x? Oh, no. This is the next one. Secant u equals cosine x. U equals cosine x. The one more. The answer of the question of the Jack. Tan x is not equal to, this is sine x or cosine x. You're right. This is not equal to sine x minus cosine x. No, don't change. So really be careful. Tan x is, you're right, sine x over cosine of x. This is the idea. So you can change it. Sine x over cosine of x tx. You're right. The change like this. Next, you have to use u substitution. U is denominator cosine of x. You can find du. Du is cosine x prime dx. So we have du equals cosine prime is negative sine. The next tip. Integrand doesn't have a -1. I want to eliminate -1. How can you do that? You multiply the both sides by -1. So like this. So we have -1 times du is negative du equals -1 times minus sine is positive sine x dx. So what's that? This is same to integral. You can change a little bit. 1 over cosine x times sine x dx form. The next integral 1 over. So this cosine of x is here, u. Sine x dx is here, negative du. So we have take out -1. Take out -1, negative integral 1 over u du. So we have minus ln of absolute value of u plus c. This is not a final. Here, you can plug back. Cosine x into u, negative ln of absolute value of cosine of x plus c. That's good? This is the idea. One more. This is not a final. I want to remove the negative sign by using this rule. Do you know this one? R times ln of x equals ln of x to the power r. This constant is going to power r. Here, this -1 is going to power. So we have ln absolute value of cosine of x to the power 1 plus c. So like this. So I want to change it to the positive exponent, 1 over absolute value of cosine of x plus c. So do you remember one more identity? 1 over cosine of x was identity of 1 over cosine of x. Do you know? Could you write your answer? What is the identity of 1 over cosine of x? What do you think? Is it right? The secant x? The secant x? Yeah, this is like secant x. Yeah, thank you. This is ln absolute value of secant of x plus c. That's it. This is the final answer. So you have to memorize this rule. This is one rule. integral tan x dx is ln of absolute value of secant of x plus c. You have to memorize this rule. So memorize this rule. This is one important rule to memorize. This is the formula. The next tip. So here we have it. So like this. Integral in natural exponential function. Similar. What is e to the x prime? Do you remember? What is e to the x prime? What is the answer? Answer is, yeah, e to the x is right. Yes, thank you. E to the x. Yeah, e to the x. E to the x. So integral e to the x is itself. So e to the x plus c, right? So give example. Integral x times e to the x squared dx. How can you solve this problem? As I said before, in this case, don't distribute like this. No, don't do that. So my previous explanation. So don't do that. So how can you solve this problem? Do you know some methods for solving this problem? Do you know? So what kind of method is possible for solving this problem? How can you solve this one? Do you have any idea? Integration by parts? Not yet. So if you try to solve this kind of problems, so don't use integration by parts in chapter 6. One more. In this case, you cannot use integration by parts because we don't know this one. You can find integral e to the x squared. We don't know, so we cannot use integration by parts. So what's like a main rule? So we are going back to my first lecture today. So I talk about two kind of methods for solving integral problems. First one, formula. One example is integral sine x dx is negative cosine x plus c, like a formula. The another method is u substitution. So in chapter 6, we use two methods for solving integral problems. Formula or u substitution. In this case, we don't have a formula. We can use u substitution. This is the idea. What is u? So what is u? X squared. Yeah, this is x squared. So y, x squared prime is 2x dx. You have to ignore coefficient 2. X dx in integrand. This is like idea. Yes, thank you. All of guys, u equals x squared. So du is x squared prime dx exactly 2x dx. The next, this is not good. Divided by 2. 1 over 2 du equals x dx. Next, substitute. This equals integral. Here, x squared equals u. You plug e to the u. Next, x dx. X dx is here, 1 over 2 du. You take out coefficient 1 over 2 e to the u du. The 1 over 2 times, what's that? Integral e to the u is e to the u plus c. Next to change back. 1 over 2 e to the, what's u? U is here, x squared. So x squared plus c. That's it. This is the whole idea for solving this problem. Next one, integration in general exponential function. So do you remember what is a to the x prime? What is a to the x prime? So do you remember a to the x prime? Do you know? So a to the x times ln of a is right. A to the x, yeah, a to the x times ln of a, yes. Yeah, thank you, all of guys. A to the x times ln of a. I wanna divide the both sides by ln of a. So like this, ln of a. So we have it. Next, this is a constant coefficient part. Ln of a is going to inside. It's possible. The one example is the 5x squared prime is 5x squared prime. It's always the same. You can take out or going to inside. It doesn't matter. So this is going to inside. So we have it. So next, what is integral a to the x dx? Exactly antiderivative 1 over ln of a times a to the x plus c. So that's it. So we have this result. So we try to solve this problem. How can you solve? How can you solve this problem? So what kind of method do you want to use for solving this problem? So what kind of method do you want to use? Yes, U substitution. Yeah, thank you, a lot of guys. This is U substitution. The U is power sine of x. The du is sine x prime dx. Sine x prime is cosine x dx. The next substitute. This is same to, this is sine x is u. You plug into here. Integral 3 to the u. Cosine x dx is here. du. You can use this rule. So what's that? 3 to the u over ln of 3 plus c. You change back. This u is here. Sine of x. You plug back. The 3 to the sine of x over ln of 3 plus c. So that's it. This is whole idea for solving this problem. The next, integration in general logarithmic function. So we can use this one. You know, the change of base. The log x with base a is ln of x over ln of a. This is like a key part for solving this problem. I'm gonna give one example. Integral log x with base of 5 equals over x dx was the best way. You can change general logarithm function to the natural logarithm function. So we have change like this. This is the same to integral log x with base of 5 times 1 over x dx. This is the same to integral. The log x with the base of 5 is changed like this. We have ln of x over ln of 5 times 1 over x dx. The next, ln of 5 is coefficient, constant, take out. So we have integral ln of x over x dx take out 1 over ln over 5. The next, How can you solve this problem? You have to use U substitution. U equals ln of x. The du is ln of x prime dx. This is same to du equals 1 over x dx. So let me see. Here you keep 1 over ln of 5 integral. This one, ln of x is u. Here, 1 over x dx is du. So we have 1 over ln of 5 times, you can use power rule. This u to the power 1. So 1 over 2u squared plus c. Same to 1 over ln of 5 times 1 over 2 times what u? Change back. The u is ln of x again. Here, ln of x squared plus c. We just simplify more. The numerator is ln of x squared over. This is bottom one, 2 times ln over 5 plus c. So that's it. This is the whole idea for solving this problem. What's the key? You can use this one. Like this. Do we have it? The next tip. We think about more examples. Here, we have 2 problems. So like this. How can you solve this problem? Do you know? Do you have some idea for solving this problem? How can you solve? You can use which method do you want to use for solving this problem? So we cannot use formula. In this case, we have to use U substitution. What is U? So what is U here? U equals ln of x. Is it right? ln of x. It's good. So one more. So do you know difference between this kind of things? ln of x squared is right? This is right? ln of x squared equals 2 times ln of x is right? Yes? Yeah, this is true. Yes. Yeah, thank you, the other guys. What is second one? The second one has, like this is 2 times ln of x. Is it right? This is right? What happened to the second one? The second one is true. This one is right? No, 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 no. Yeah, thanks. No, don't do that. Here, this first one, you can change it. This is possible. U cube, e to the 6 or e to the 6, 1 over x times the ln x squared is 2 times ln x. You can change it like this, but here, no, don't change. This is like one key. You can use U substitution. U is exactly ln of x. So U is ln of x, this problem. U is ln of x. The du is 1 over x dx. So we have it because ln of x prime. So first one, yes. So ln of x squared is here. You can change it to the 2 ln x. You have to use, change it a little bit. So take out 2. So 1 over 2 you can take out. The next is you have to use U substitution. You plug U into here. So we have, this is same to 1 over 2 integral 1 over U. 1 over x dx is here. du. Change. One more. How can change lower limit, upper limit? You plug e cube into here. So we have g over e cube is exactly this one. G of e cube. You plug e to the 6 into here again. So we have g to the e to the 6. So we have it like this. Next, simplify. What is g to the e cube? This is the same to plug e cube into here. The ln of e cube. What's ln of e cube? Don't you know what is ln of e cube? What is like a simplified form? The ln of e cube is, you know, yeah, you can use cancellation equation. Cancelled 3. The g to the 6 is same. ln of e to the 6, we use cancellation equation, just 6. So we have 1 over 2 equal 3 to 6, 1 over u du. So like this. The next keep equal 1 over u is ln of absolute value of u from 3 to 6. 1 over 2 times, so this is ln of, you can keep this one, plug 6 into u minus ln of 3. So we have 1 over 2. You can change it. This one to the, do you know this one? So ln of x minus ln of y equals ln of x over y. So we have ln of 6 over 3. So we have 1 over 2 ln of 2. So we have it. This is the whole idea for solving this problem. So like this. Second problem, similar. You plug u into here. This is same to integral, same. 1 over u square. The 1 over x dx is here, du. Same. You plug e cube into g. G of e cube is the same. This is g of e to the 6, also same. So like this. And g cube is plug e cube into here. So we have same things. ln of e cube cancelled 3. G of e to the 6, ln of e to the 6 cancelled 6. So we have it. You can use power rule. This is 1 over negative 2 plus 1 u to the negative 2 plus 1 from 3 to 6. This is same to here, minus 1. This is u to the minus 1 is 1 over u. We have negative 1 over u. Oh, yeah. Thank you. So can you turn off your microphone? This is like better. Sometimes the other guys cannot hear clearly. Could you turn off your microphone in your Zoom? Thank you. The minus 1 over u from the 3 to 6. So we have plug 6 into u minus 1 over 6 minus plug 3 minus 1 over 3. So exactly negative 1 over 6 plus 1 over 3. I want to find common denominator, the 6. You multiply second one by 2 over 2. This is negative 1 over 6 plus 2 over 6. Final answer is 1 over 6. This is the whole idea for solving this problem. So like this. Yep, no problem. So you can turn off. Yeah, sometimes you forgot. Don't worry about it. Yeah, this is like 1/6 that we have this answer. So next problem. So we have opposite ones, right? integral 1 plus e to the x squared over e to the x, e to the x over 1 plus e to the x squared dx. We have two different kind of things. How can you solve? The first one. So what happens? Bottom one is only one term. Top one has several terms. In this case, you have to expand. Expand. Do you know expand form? The numerator is like this one. integral the 1 plus e to the x times 1 plus e to the x over e to the x dx. You have to expand here. The Kensho Foil rule. 1 times 1 is 1. The outer inner. 1 times e to the x plus inner e to the x times 1 is 2 times e to the x. The last one, e to the x times e to the x is e to the x squared over e to the x dx, right? So next one, you have to split 1 over e to the x plus 2e to the x over e to the x plus e to the x square over e to the x. You have to cross out, integral was like 1 over e to the x, exactly e to the negative x, plus second is only 2, plus last one is e to the x dx. So let me see. How can you find integral e to the minus x? So you need to memorize this formula is better. So I can give one general form. Integral e to the kx dx. How can you solve? You can use u substitution. U equals kx. Find du. Du is kx prime dx. So we have du equals k dx. Next one, divided by k. This is same to 1 over k du equals dx. And change. Integral here. Kx is u. The dx is here. 1 over k du. 1 over k du. You can just take out 1 over k. 1 over k integral e to the u du. So we already know integral e to the u. 1 over k e to the u plus c. And change back. This u is here. Kx. 1 over k e to the kx plus c. So it's better. You can memorize general rule. Integral e to the kx equals 1 over k e to the kx. The one example is integral e to the 5x dx. How can you solve? 1 over 5 e to the 5x plus c. So that's it. This is the whole idea. The same. So what's that? This minus 1 is like k, 1 over negative 1 e to the minus x plus. Integral 2 is 2x. Last one, integral e to the x is e to the x plus c. So you can change. Negative e to the minus x plus 2x plus e to the x plus c. So that's it. This is your final answer for solving this problem. The next one, you can use u substitution. This is denominator is like u. The du is 1 plus e to the x prime. 1 prime equal to 0. E to the x prime is only e to the x. So substitute. 이네걸. You can plug u into denominator 1 plus e to the x. This is u square. So e to the x dx is here. E to the x dx is du. So we have it 1 over du. So 1 times du. You can change it to the negative exponent. You can use antiderivative, negative 2 plus 1, u to the negative 2 plus 1, plus c. Next, change back. The before, change back. The you need to simplify. 1 over negative 2 plus 1 is negative 1 over. The u to the negative 2 plus 1 is 1 over u. So like this. Next, change back. This u value is 1 plus e to the x into here. Final answer is minus 1 over 1 plus e to the x plus c. So we have this answer. Is right? So let me see. What's like the main idea for solving integral problem? Formula or u substitution. This is like two main parts. You have to memorize these two kind of things. The next tip. This is the two last one here. First one, how can you solve this problem? How can you solve this problem? Do you have any idea for solving integral 2 to the 10x over cosine square of x dx? So do you know how can you solve this problem? Any idea? U equals to secant tangent. U sub is right. Yes, U sub. What is U? The my question. What is U? What is U? Cotangent. Cotangent is right. Is right? Cotangent. The my question. What is tangent x prime? What is tangent x prime? Do you know tangent x prime? Yes, secant square of x. Thank you. You can change it. Secant square of x is 1 over cosine square of x. What happens? 1 over cosine square of x is here. Yes. What's u? U is 10. You can take the derivative power 10x. 10x prime is in the integrand. This is a good choice. So 10x is u. So you can use idea, u substitution. U equals 10. du is 10x prime dx, secant square of x dx, same to what? 1 over cosine square of x dx. So how can you solve integral 2 10x over cosine square of x dx? This is 2 to the 10x is here, u. 1 over cosine square of x dx is here, du. Do we have it? Simple form. You can use formula. What's the formula? 2 to the u over ln of 2 plus c. The final answer is 2 to the change back. U is 10x over ln of 2 plus c. This is ln of 2, the plus c. That's it. This is your final answer for solving first problem. Second one, you have to use u substitution. Is it right? U substitution. This is a complicated one. What is u? What is u? Use a sign. Use a sign. What is u? What do you think? It's the last one. What is u? What is u? Don't think about it. What is u? What is u? U is sin x. You can try here. U is sin x. You can choose u equals, yes, sin x The du is sine times cosine x dx and change. This integral ln of sine x u cotangent dx but cosine dx. We have trouble. We have trouble. It's not good. It's not good. What is u? What is u? Sine x is not good choice, I think. What is u? U is, do you have an idea? U? U is here. What is whole? ln of sine x prime. You can use sine x prime over sine of x. Sine prime is cosine x over sine x. What's cosine of sine? What's cosine of sine? Do you know what's the identity of a cosine of sine? Yes, we have it. Cotangent x here. What's the idea? Whole ln of sine of x. That's right. This is the idea. You can try one thing. So u equals sine x failed. You can choose another one. The ln sine x is one good choice. We can use identity here. So du is this one prime, sine x prime over sine x, cosine x over sine x dx is cotangent x. So what's that? This is same to integral ln of, sorry, not ln, erase here. Here, ln sine x is exactly u, just to u. The cotangent x dx is here, du. du. We have a simple form. We have 1 over 2 u square plus c. You can change back. This u is here. ln of sine x, 1 over 2. You have to keep quantities. ln of sine x whole square plus c. That's it. This is the idea. It's good. This is the whole idea. This is all for today's lecture. So if you have any question, just let me know. I will explain your any question. But now, so if you don't have any question, so you can leave. This is like June. You can leave. And any question, so write your question on the chatting board. I will answer your question. So if you don't have it, yeah, you can leave this live session. Yep. I'm just waiting.